access. But unfortunately, I'm gonna block some people. Is that okay? So let me know. But you can always watch it. Can I see? You're gonna be my camera person. Is it blocking anybody? No. This. Is that blocking anybody? You? All the way in the back? You should be okay, right? Okay. So, yeah. So the first exponential rule is called product rule. The product rule says a to the m times a to the n is equal to a to the m plus n. Did you guys ever seen this rule before?
Yeah.
Yeah, you know this, right? Okay. So I will show you what the small math gonna goes, which is the math here is the example. So example is 2 to the third power times 2 to the second power is equal to what? To the fifth power. But just say assume that we didn't know. Assume we didn't know. We do the slow motion. It's going to be like this. So this is 2 to the third power. This is 2 to the second power. So therefore, it's 2 to the fifth power. And we already know that because of the rule. But why do we need to use a rule if I can write out every time? It's faster. What if it's a 2 to the 298 power? Then do you gotta write 2 several times? No. You're gonna write it as it is, so you're gonna write it like you understand the rule, and the rule is gonna apply right away. So the second rule is a to the m over a to the n is equal to a to the m minus n. And for me, I can never remember like which subtract which. So here's the rules that you're gonna understand. It's always top minus bottom. Are we okay here?
Yeah.
Top minus bottom. So then it's gonna be 2 to the, let's say, fifth power over 2 to the third power. Well, if I do slow motion math, which is I can always show you this way, but I show you just for you to understand. I can cross those out. So that's equal to 2 to the 2. Or I could have said, if I apply the rules, it's going to be top minus bottom equal to 2 to the 2. That's faster. Are we okay with second rule? This is called product rule. It's called quotient rule. We don't care about a name. The name is not very, very important. The third rule is this one. This one's kind of tricky. 1 over a to the negative n is equal to a to the n over 1. That's where I kind of tell you. Or a to the negative n over 1 is equal to 1 over a to the n. So according to mathematics, you should not have a negative exponent. If you have a negative exponent, you're going to change sign, becomes a positive exponent. Okay, it becomes positive exponent. So just think about how many of you guys have sisters and brothers and have bunk bed at home. Anybody ever sleep on a bunk bed before? Okay, so you sleep on a bunk bed before. Do you like to sleep on the top or the bunk bottom?
The top.
The top. Did you ever fall off the bunk bed before?
No, not really.
I did. On top. It sucked. While you're dreaming, you fall off. That was the worst that can happen to you. So just imagine that you are on the top. Okay, so if I were on the top and I'm not feeling secure, I feel insecure, it's negative, right? It's a negative sign, I'm not feeling happy. So I can always switch to the bottom and become happy. So that becomes positive. When you switch side, you become happy. When you have this, when you're on the bottom, you're upset at him. He doesn't like to sleep on the bottom because he feel like it's oppressed. But you can always move to the top and make it happy. A to the n over 1. So remember, this one I can always rewrite as a to the n over 1. Also, we're going to talk about some other answer all the way in the back. He was telling me about a negative sign. I'm going to talk about that. So what if it's 2 to the negative 3 power? What does that mean? 1 to the 2 to the third power. Does that make sense? And how about 1 over 2 to the negative 4 power? What does that mean? Right, so that's it. It's a very easy rule. The fourth rule is very, very given. Do you guys know anything number to the 0 power? What is that equal to? 1. Anything to the 0 power is equal to what?
1.
So a to the 0 power is what?
1.
It's 1. So we're gonna prove that. Okay, so he knows it. Great for him. Okay, it's great for him. You don't know it, it's okay. But he doesn't know how to prove it.
That's true.
Okay, so we're gonna show you how to prove it. If you know your answer, you don't need to be like, putting other people down. Because you don't know the true things behind it. Even you think you know, but still a lot of things you don't know. So much thing you don't know. Actually, you don't even know anything to the 0 power is 1. And the worst is you don't know what the 0 to the 0 power is. Okay? And you don't know how to prove.
What is 0 to the 0 power?
0 to the 0 power is actually 1. Does it make sense, right? 0 to the 0 power is 1. That doesn't really make sense. But the proof of it requires a lot more higher level. But I will go over it one day when we get to that level. But right now, we need to know why anything to the 0 power is 1. We're going to show you a simple proof. Everybody see proof, they get scared. But it's not scary. It's not scary. And nobody ever told you. I can bet not a single teacher here ever told you why is anything to the 0 power is 1. I'm going to show you a simple proof. 2 to the third power is equal to 8, right? It's 2 times 2 times 2. 2 to the second power is equal to what?
4.
2 to the first power is what? 2. Okay. Did you see the pattern? The pattern is from here to here is what? So 4 divided by 2 is equal to 4. 2, right? Sorry. And then, what's the next number? 2 divided by 2. That's why anything, it will apply to anything. Because the other one is going to divide by 3, 3 to the 4th power, 3 to the third power. You just divide each times. So when you divide it by, eventually anything to the 0 power is 1.
So it's divided by itself?
Yes. And then you can do the next thing too. We're going to prove the negative exponent rule too. So what's the next one? 2, what is it? 3, 2, 1, 0. What's the next number? Negative 1, right? So you divide it by 2. So what's 1 divided by 2? That's why it's negative power. So a lot of you guys just say, oh, my teacher asked you to memorize this. I'll just memorize for the test. I'll forget it the day after. But the thing is, you cannot teach your grandkids math. But if you understand it, you might be able to teach your grandkids math. My goal is make sure you can teach your grandkids math. That means that thing's gonna stay so long, you're gonna say, oh yeah, Mr. Ye told me 20 years ago. Well, when you have grandkids about, what, 40 years ago, 40 years later. So then you can say 40 years ago, my teacher told me this, I still remember. Here's how do you prove it, and here's how do you memorize it. By then you probably don't need it. By then it's probably like technology is so advanced, but you don't need it. But a to the 0 power is 1. So anything to the 0 power is 1, which is very special. The fifth rule is, the last rule. A to the m to the n power. So what's the difference between these two? Has parentheses. Right, the parentheses makes a difference. So how does a parentheses, how would I read it though? It's actually a to the n power, okay, to the n power. Okay, so they are power to the power. And like this is just 2 together. Oh, also I forgot to mention one thing, is that A has to be the same. Okay, A has to be, they have to have a same base. So you cannot say it's 2 to the 5th power times 5 to the 2nd power. They can be 10 to the 10th power. No. They're gonna equal to 2 to the 5th times 5 to the 2. They do not combine because they don't have the same base. But if you have the same base like this, then it's gonna be the 7th power. A lot of people get confused on those small parts. You cannot join the base together. The same base you can join becomes 1, and then just add exponents. Next thing is a to the m times n to n. Here is equal to a to the m dot n dot is times. It's called product. Okay, so why is this one different than this one? We're going to show you. This one's 2 to the 3 power times 2 to the 2nd power. But this one, it says 2 to the 2nd power to the 3. Like this. But that means there's a parenthesis. Remember that parenthesis rule applies. That's equal to 2 squared times 2 squared times 2 squared. That's equal to what? 1, 2, this product, right? It becomes like here, 2 plus 2 plus 2 is equal to 2 to the 6. So that's why the faster is you're going to say, okay, 2 to the 2 times 3, that's equal to 2 to the 6. And that's a good thing.
So only the exponent gets bigger, not the number?
This one is 2 to the 2nd power to the 3rd power. So those two things are going to multiply, not add. It's not like this one. People get confused with this rule and this rule. And the reason why people always, for me, people always not do well on this test is because people thought it's too easy. And they end up screwed up on the simple parts. But they think too easy, but everything's going to be, whatever. But so never think anything that's too easy. Always pay attention to small, tiny detail. The small, tiny detail is whatever your Algebra 1 teacher did not teach you, whatever Algebra 2 did not teach you, I'm going to reteach everything for you. And I'm going to reteach everything for you in the way that anybody can understand. Next thing, the last row is different. Last row is actually almost close to 7th grade. So we went to 4th grade yesterday, 5th, 6th, and 7th. We're kind of gonna do kind of like scaffolding. We're gonna do that a little bit. So the last rule is called definition or radical. Nobody ever told you this, nobody in the past probably told you how to memorize this rule, but it's a to the n to the m power, okay, is equal to, now, this one is special. This is, okay, so let me give you some name. Do you know what the n stand for? Huh?
Nicholas?
No. Is that your name?
Yeah.
Nicholas. N stand for Nicholas. N stand for index. Index. So we're gonna have a new name for that. Index. But here we're gonna call it nth roots. So also is a name to call nth roots. If I don't write anything here, then that is the square roots. Do you guys know that, right? If I don't write anything, this always means square root. If I write 3 here and a small tiny 3 right here, then it's called third roots. Am I going too fast? If I say it's 4 here, then it's 4th roots, 5th and 5th roots. Now roots is how many times the number had to multiply to get that single value. We're going to talk about that in a second. So with this one, you can change to exponents. How do I change this to exponent? It's a to the m over nth power. M over nth power. And how do I memorize that? So everything I kind of have a way to memorize, right? Those two is adding if they're multiplying. If dividing, they are top minus bottom. This is like a bunk bed. Anything to the 0 power is 1. Power to the power, that means you times the power. Now this one is kind of hard to memorize, so I get it from a teacher here that is also a wonderful teacher. Her name is Miss Nguyen. And so Miss Nguyen says, just remember, this is a tree, this is an ugly tree, okay? And the ugly tree has a power, which is a sun. So this reply as a power, right? And this is the roots, right? So it's a power over roots. Power is the m. This is the power. This is the roots. Power, roots. So you're never gonna forget. Power over roots. What I mean by that is this. Sometimes you get a question like this. 8 to the 2/3 power. And you're like, oh my God, that's SAT questions. 8 to the 2/3 power. What do I do with this? Have you guys seen this question before? 8 to the 2/3 power? Yes? Who says yes?
I saw it once and I had no clue what to do.
Oh, you have no clue what to do. But from now on, you're going to have a clue what to do. Okay? So I'm going to show you how to do it. 8 to the 2/3 power. The number 2/3. So you say, okay, now can I change to the radical? Can. So how do I do that? I'm going to do 8. So what do I put here?
2,
3.
3, right? Index and root, and right here, those are roots. This is roots, this is roots, right? And this is 2. Oh wow, then we are getting somewhere. Now, not only that, so also one thing you have to know, in order to grow a tree, you need to grow roots first before you grow leaves, right? So you're gonna do roots first. Here's why you do roots first before the power. When you get to this situation, you do the roots first, the number is much easier to manage. Okay? So what I will do is, this one here, I will do the roots first. Some people say a squared is 64, but they don't know what's the root of 64 because the number gets too big. But we know what's the root of 8. How many of you guys know what's the roots of 8? I'm going to call random you. Do you know what's the roots of 8? Nope. The roots of 8?
No.
Okay, good. So those of you guys got it wrong, it's okay. Now I'm going to give you a clue for the third person. That means 3 of the same number multiplied together is going to give me 8.
2.
There we go. So it's 2, right? So let's say equal to 8 to the 3rd roots and then square. So I'm going to rewrite this way. I'm going to do the roots first. If I do the roots, it's better because it's harder to figure out what's 64. What's the number? 3 times number is going to give me 64. But in this case, it's equal to 2 squared. That's equal to 4. So SAT questions on all of this, right? You're like, wow, this is a lot of work, but it's not. It's really easy. You're gonna see. You're gonna get hang of it, and it's gonna be very, very easy for you in an instant. Okay. So we're gonna show you questions. Sorry, I was cooking something there. So we're gonna do a couple questions here with me. One of them is gonna be slightly easy, and one of them is gonna be a little bit harder. Okay, so here's a question I want you to do. So this is algebra 1. So we're gonna go here. So here's a question. I want you to do this question. 2x to the fourth y to the negative 3 times by 4x to the square y to the fourth. I want you to times two things together. This is algebra 1 and pre-algebra. So here's the thing, it's times. That means everything's gonna times together, right? What do you think? Yeah.
I would say distributive property, but
It's kind of distributed, yes, you're right. Distributed is like multiplying.
you said you can't combine the exponents if they're not the same base and they're not the same base. So would you
Okay,
want-
so do they have the same base? Let's look at 2 and 4. Do they have same base? No. But can those 2 and 4 multiply together?
Yes.
Can I get 8?
Yes.
How about x to the 4 and x 2? Do they have the same base? Yes.
Yes.
So what is the exponent gonna do? It's gonna add.
Oh, so when does it multiply?
We're gonna get there. That's why some people get confused. So it's gonna be ax to the 6, y to the 1.
Y to the 1 would be y, right? Y to the
Yep.
Because they have.
You wanna try one more? It's pretty easy. Now this one I'm gonna give you a little bit tricky. Now I don't like negative exponents, okay? I don't like negative exponents, so I'm gonna tell you that. Your answer should not have a negative exponents. What'd you get?
I got 12x to the 0, and then y to the 8 over 1 power.
Y to the what?
8 over 1. Negative 8.
Okay, so first of all, let's take the negative 8 part first. Okay.
Oh yeah, 1 over 8.
So now, yeah, that's fine. I think I know what you're saying, but I think you told me the story kind of off when you try to describe it. But x to the 0 is what? 1. Right? Y to the negative 8 means what? 1 over y to the 8, right? So it'll be 12 y to the 8. That's it.
Is homework on Edmodo?
The homework is always on Edmodo every day before 5 o'clock. And the new person need to know in the binder.